Hello, I'm Doug Watches. Welcome to the Locksmith DVD training program. In this course, we are going to explore ways that you can begin working and making money as an automotive locksmith. This course is primarily designed for those who already have some basic locksmithing skills and now want to expand into automotive locksmithing. If you have absolutely no locksmithing experience, you will still probably be able to understand most of what is presented in this course. In this course, I'm going to present a great deal of information. It is a long course, over 3.5 hours. It is nearly impossible to comprehend all of the information in one viewing. You'll probably find it necessary to view the video more than once. I would also suggest stopping the video and making notes along the way. Each section of the course will focus on specific skills, techniques, or knowledge. Although I am using Fords for most of our examples, most of what is presented applies to nearly all manufacturers. Automotive locksmithing can be very challenging, and you want to approach it with great caution. You'll only want to take on work for which you have acquired the skills to complete the job. Automotive locksmithing is rapidly changing. Even without new changes, it can take considerable time for a person to feel comfortable in this field of work. I want to warn you that when it comes to automotive locksmithing, you do not assume anything. Verify everything and expect to find the unexpected. Because automobile manufacturers make mid-year changes, and because resource material may have mistakes also, it is not unusual to find the unexpected. In this course, we are going to focus on Ford locks. However, the methods that I am going to demonstrate will work on most cars. Later in the course, we're going to learn how to get the key code from the VIN number just by making a phone call. That is a very easy way to make a key in about 15 minutes, and it will work on nearly all cars made after 2000. If you take your time and master one type of lock at a time, it will not be long before you feel confident. I'm going to try to provide a path of learning for you to begin earning money very quickly. At the same time, as I said earlier, I want to urge you to use extreme caution. Do not attempt to take on work until you have had a chance to practice with the same type of locks and become proficient with that type of automobile and locks that you'll be working on. The best way to get experience in automotive locksmithing is to go to a salvage yard and work on those cars first. If you make a mistake or find that you are not able to complete the job, you're not going to leave some individual stranded. It is a safe environment in which to practice locksmithing skills. I would like to strongly urge you that when you start out, do not take on any work that requires you to disassemble any of the locks or any part of the vehicle. In recent years, I have made it a strict rule that I no longer pull steering wheels with airbags, nor will I pull a door panel with an airbag behind it. If I cannot make the key in some other way, I will pass on the job. When a locksmith is called out to make a key for the car, he must start without being able to turn on the ignition. Therefore, he has no idea of the condition of the airbag system before he starts. Once the job is finished, if the airbag light comes on, it is difficult to say who caused the problem. Most of the cars made today allow you to access the ignition lock without pulling the steering wheel. Therefore, there is plenty of opportunity to work in this field without pulling steering wheels. It is my recommendation that as a new automotive locksmith, you only work on cars that meet certain conditions. 1, the car still has all of the original locks. And 2, the locks are in good working condition. You can normally determine if the car has its original locks by asking the owner if one key fits all of the locks. Most cars made since about 1990 came with only one key. If the owner says there were 2 keys, one for the door and one for the ignition, then we need to check our reference books to see if that car came that way from the manufacturer. If we suspect any of the locks have been changed and are not original, then you should probably not take the job until you become more skilled. Ultimately, you're going to have to decide on every job that you are offered if you feel competent that you'll be able to complete the job with the skills that you have. Before we accept the job, we will need to look in one of our books to see if the car uses a transponder or if the keys are high security keys. By high security keys, I'm referring to keys that are often referred to as sidewinders or laser cut keys. These keys are easily recognizable because they'll have a groove down the side of the key. At the end of the course, I'll talk more about transponders, but for right now, just know that it is my recommendation that as a beginning locksmith, you do not start out working on cars that have transponders or high security keys. Also, a word of warning about broken keys and ignitions that will not turn. If a key is broken off inside an ignition, or if the ignition will not turn, those problems often involve pulling the ignition lock. So those are jobs you may want to put off for a while. We'll learn more about how to handle those situations in later courses. If you get to a job and find it is too difficult for your skill level, the best thing to do is pass on it. Just tell the customer of your concerns and suggest they call someone else. When you complete this course, you should know the basic tools used in automotive locksmithing. You should be familiar with how a wafer lock works. You should be familiar with the Ford 8-cut, 10-cut, and pin tumbler locks. You should be familiar with 4 different types of readers. You should be able to find basic information about auto locks using AutoSmart and FastFacts reference books. You should be able to find the model year from the VIN number. Be able to make a key using readers and impressioning. Be able to use a fill program. Be able to make a key using tryout keys and progressioning. And be able to read a progression chart. You should know how to find the deepest wafer in a lock, be able to determine the working side of a key, have a basic understanding of transponders and their use, be familiar with 3 different kinds of programmers, and have a general idea of how to use a programmer. This course is divided into 18 parts. Part 1 is Tools and Resources. Part 2, Understanding the Wafer Lock. Part 3, Comparing Ford Locks. Part 4, Wafer Reader Tools. Part 5, Vehicle and Customer Identification. Part 6 is a demonstration of the reader tools. Part 7, Completing a Key using a fill program. Part 8, Using tryout keys and impressioning. Part 9, Using tryout keys and progressioning. Part 10, Ford pin tumbler locks. Part 11, Making a key using the VIN number. Part 12, Transponders. Part 13, Programmers. Part 14 is Programming a 99 Ford Expedition. Part 15 is Programming a 2007 Dodge Dakota. Part 16 is Review. Part 17 is What Tools to Buy First. And Part 18 is Suggested Practice. In this course, we are going to look at a number of tools and resources that you can use to generate car keys. It is not necessary to have all the tools that I'm going to show you. Some of the tools I'm going to demonstrate just so you'll be familiar with them. You will need to have some way to cut car keys from code. I recommend the HPC 1200 code machine or an equivalent from some other manufacturer. If you have limited funds, another possibility to consider is a key clipper, like the one from A1 Manufacturing called Pack and Punch. The Pack and Punch tool allows a person to cut car keys from code by hand. One of the nice things about those tools is they do not require any electricity to operate. We'd like to make you familiar with some resources that you may want to try to pick up and have on hand, as they will probably prove useful to your work as an automotive locksmith. First book is FastFacts. Has all kinds of data on cars and truck locks. We're going to get into discussing these more later and show you how they work. I want to just pretty much show you what's available right now. A similar resource, AutoSmart, has two books, one for foreign automobiles and one for domestic automobiles. And again, all kinds of information about the locks and so on the card, how to make the key and this kind of thing. For a beginning locksmith, I would really recommend pick up a copy of the AutoSmart books. The National Locksmith, a publication that you can subscribe to, they normally will have an article in each issue about automotive locksmithing. This article talks about code cutting machines. So National Locksmith is worth subscribing to. Another service that they offer through the National Locksmith is called the National Locksmith Automobile Association. And this is a separate subscription. If you join this, you'll get a publication like this about once a month. And they take a new vehicle and will go through all of the different locks, all kinds of details about how to service all of the locks on the car. You see, here's one on 2014 Chevy Silverado, 2013 Malibu, the 2010 Camaro, and so on. And when you subscribe, you will get a CD that contains most of their past issues as part of your subscription. So this is, I think, very worthwhile. Pick up a Stratec catalog. There's all kinds of information in here that will be useful to you just to learn about what all is available. And they have breakdowns of the locks and so on that could prove quite helpful. So I would pick up a Stratec catalog. Also ASP catalog. It's just full of data about automotive locks. ASP is a distributor of all types of automotive locks and lock parts. Get a catalog for Lockmasters. They have a lot of automotive tools available that you can purchase. Same with HL Flake. Would be worthwhile to get one of their catalogs. Get an ILCO guide. Now this goes with their programmer. But even if you don't have their programmer, there's good information in here about what cars have transponders and what cars can be self-programmed and this kind of thing. Also by ILCO, they put out a auto truck key blank reference every year. Try to get a hold of one of those. And then Michael Hyde's transponders. Now he does have a later version out. This is 95 through 2010. There is a later version of this, but if you think you're going to do programming of transponder keys, which we'll talk about later in the course, this is a very good resource. Okay, this is the HPC 1200 code machine. There are other manufacturers, other brands of code cutting machines, but you're going to have some type of equipment to cut car keys from code. This is a pack and punch. It's a hand key clipper. You can cut your keys with this. You don't need a code machine or electricity. It's a great little device to have, and it's another option for cutting car keys. And I'll show you how this works later on in the course. If you want to get into programming transponder keys, you're going to have some way to program them. This is the MVP Pro by Advanced Diagnostics, and it will come with a very valuable resource for transponder keys. And so that will come as a set if you do get that particular programmer. This is another programmer, the TKO, Transponder Key Originator. We're going to look at both these transponders, both the Advanced Diagnostics and the TKO later in the course, and we'll program a key with each one. Here's a couple of tools from Advanced Diagnostics that are not totally necessary, but you may find helpful to pick up down the road. This one here detects transponder signal. If the transponder or the transceiver ring is putting out a signal, you hold it right next to the ignition and put the key in, and if you get a beep, it detected a signal. Some vehicles you have to turn the key to the on position before it will beep. The other tool here checks the OBD port to make sure that the wiring on it is not going to destroy your programmer, and also tells if you have power. So it does two things. One, tells you if there is power to the OBD port, and second, if it is safe to use your programmer with it. I've never seen it. I have heard that there's been problems that there'd be some type of wiring change in the car and it could short out the programmer. So that's not covered under warranty, and it would be a pretty expensive loss. So I normally will check the OBD ports before I plug into them. A couple of tools that will become your very best friends in automotive locksmith work. Some type of scope with a probe on it that you can stick in the lock and manipulate the wafers. Lighted scope is the way to go. This has a light that will light up inside the lock, and I'll try to demonstrate this more later. Another tool that you're going to want to have is a digital caliper. You absolutely have to have some way to measure the cuts and spaces of a key when you're doing automotive locksmith work. This tool is an easy reader. It's a tool that will allow us to read the cuts of a lock without taking the lock apart. And as we get into the course, I'm going to go through several different types of tools that will allow us to do that. And so a whole section of the course is going to be committed just to using these kinds of tools. These are tryout keys. We're going to talk about tryout keys and use tryout keys throughout the courses. There's two different manufacturers. This set here is Baxter. Another company that makes tryout keys is Aero Lock. So those are the two largest manufacturers that I know of tryout keys. And again, we will talk about these during the course. Now, a few little specialty tools you'll find helpful. These little dust cover holders from HPC come in real handy, and I'll show you how those are used in a few minutes. But they basically go in the door lock and lock the dust cover back so it's out of your way. This is a probe. It has an offset handle so you can keep your hand back. Oftentimes it's helpful in looking into a lock. You're going to need just some basic tools also. Vice grips. You're going to need some files and a good impression file. Basic screwdrivers and pliers and that kind of thing. Set of lock picks. You're going to find helpful at different times. So just your basic locksmith tools that you normally use are going to come into use in automotive locksmithing also. Now these are a couple of things I'd recommend that you get. Most all the manufacturers of the reader tools recommend that you use some type of cleaner in the lock, some type of degreaser. And this electronic cleaner works pretty good for that. But when I'm using my reader tools, I really want to make sure that the wafers are very free. They can slide very freely in the lock. And I will also, I normally spray in the cleaner and I'll wait for a few minutes for it to work. And then I will use this lock shot, which is designed for locks and to make them very, very slippery. I want to point out to you that there is a new jaw that HPC put out for their code machines that is designed to hold the GM 10 cut key better and the Ford 8 cut key. If you find you're having trouble holding these keys in your key machine, you may want to look into ordering this new jaw. It's part number GMFJ-1. Another resource that you're going to need is some way to keep your key machine tuned up and cutting accurately for both spaces and depths. For automotive work, many locks are very precise. Many are not. Many locks have a lot of leadway. The cuts and spaces can be off, quite a bit. But on the other hand, you've got the other side of that story where they have to be right on the money or that key is not going to work. So this is a kit that comes for the HPC 1200 code machine. Most automotive locks today are wafer style locks. Therefore, it's critical that we understand how the wafer lock works. So before we start looking at automotive locks, I want to take some time and just study a small wafer lock and make a key for it. I would suggest that you watch this part of the video before attempting to do the actual exercise of making a key. Once you've finished watching this section, I do think it's very important for people who have never done this before to actually get a wafer lock and make a key for it. Now, the fastest way to get a wafer lock is simply go to the hardware store and buy one. Just ask the clerk for a wafer lock or a cam lock like the one you saw in the video. That will allow you to get going right away with this activity. While you are at the store, get a couple of uncut key blanks for the lock. Now, if you're an experienced locksmith and you've already worked with impressioning keys, there's probably no reason for you to complete this exercise. Now, if you are totally new to automotive locksmithing, I have a suggestion that you may want to try and do an activity with a cam lock to just become familiar with cam locks and how they work and the structure and functions and so on. So I'd suggest going to the hardware store and just buying a cheap $5, $6 cam lock. And let's take it apart and look at it and also see if we can make a key for this lock. And so while you're at the hardware store, go ahead and ask for a key blank. Tell them you want just a straight key blank uncut that will fit this lock, and they'll normally sell you one. We need to take the screw off the back. There'll be a big nut on there. Take that off. Get that out of the way. Okay, so we take the plug out of the shell. We can see that there are 5 wafers from the front of the lock, counting 1, 2, 3, 4, 5. And you can see that they are sticking up because there's a spring under each one. You can see where the little holes are. That's where the springs go in first, and then the wafers go down on top of those, and they have a little shoulder that holds them in there. We can push them out from the bottom. Now you can see that as I turn it, how they stick up on the top. The wafers stick up. They're obviously not going to allow the lock to turn. You can see these wafer chambers that when the chambers are up in there, that's not going to be allowed to turn when they're up in those chambers. Okay, I'm going to go ahead and push one of these wafers out of here. Okay, so the spring would ride underneath this little shoulder and push the wafer up into this chamber, and it would be locked. And then when you put the key in, the wafers will be flush with the shear line and the plug can turn in the shell. So the key will push down on this part of the wafer here and bring it down. If the key's cut correctly, bring it down to the correct depth to get it to the shear line. Okay, I'm going to go ahead and put this wafer back in the lock. And we're going to get on with the exercise that I wanted to show you. When it goes in, you'll feel it catch in there. This lock can be locked in two different positions. What the key does, we can see if that's, put that in there just part way. Then take the key, and you can see that the key will pull those down to where now they're down inside the plug. It's going to turn because they're out of those wafer chambers. So they're not blocking the plug from turning. What I'd like you to do, we have the idea that, again, that you put the key in, pulls the wafers down flush, the lock turns. But what if we have no key? Okay, so now we need to make a key so that it will do that. And this is basically what you're doing when you get called out to make a car key, because probably 99% of all of the locks that are on cars in operation today are wafer locks. And it doesn't matter if they're split wafers or if it's a sidewinder key or what it is, it's still, the basic design is still just a simple wafer lock. What I'd like you to do is put your key blank into the lock. You can use a Sharpie for this, or you can use a scratch-all. That will work also. We're going to just need something that will put a mark on the key blank right next to each of the wafers. Just a dot is fine. Just put a dot on there as close to the wafer as you can. Just like that. Take it out, and hopefully you're going to be able to see your 5 marks. Our 5 marks, they are there, 1, 2, 3, 4, and the last one's right on the very tip. Okay, then put your lock aside for a minute. Get a file, a round file, and now I put the marks going towards the tip. So the wafer is really on this side here. It's on this side of the mark. So I want to make a small mark, a file mark right on this side of the black mark that I made. And do that to all 5 of those. You know, not too deep, but deep enough that you can definitely see where it's supposed to be at. So if you look there now, I have 5 little file marks on my key blank. Okay, now let's take the key blank, put it back in the lock, and let's study the wafers here. We can see that already in the number 1 and number 4 wafers, those wafers are already even with the plug, or even with the top of the plug, and they're even with the shear line. You can see they're even on both sides. So 2, 3, and 5 are not. So we need to file 2, 3, and 5 a little bit so as they will not, the key blank does not pull them so far out of the plug. We can see that 2 only needs a little filing, and then 3 and 5 need more than number 2 does. So let's just do that. Okay, this is number 2. and then number 3 and 5 we said were deeper. Okay, now I'm going to primarily focus on number 2, but I'm going to do all of those, 2, 3, and 5, a little bit just to get them going. Now, if you're already fairly experienced as a locksmith, this activity probably is a waste of your time. But for a new person that's just getting into locksmithing, I really think this is a valuable exercise, especially if you're trying to break into automotive locksmithing. So let's take a look and see now. Okay, the 2 is much closer, but it's not quite flush. It actually probably would work. 3 and 5 have a little ways to go. We're going to give number 2, just take a little deeper on number 2. Just to make my point here. I don't want to waste a lot of film on this, but I do think this is, again, an important activity for people that are brand new to this. So you can see that now that number 2 is pretty flush here. It's not quite down far enough. It needs a few more file strokes there. And then 3 and 5 need to go quite a bit deeper. Now I'm not going to waste a lot of film time on doing this, so I'm going to file this off camera and then I'm going to show it to you. Okay, I'm back with the key that I was filing, and we can see that if we try this in the plug, it pulls all of the wafers down flush. So it took about 7 or 8 minutes, I would say, to file that down. And you do just like I was showing. You just file a little bit, put it in, and see if it's right. If it's not, you file a little more until you get it correct. And now let's compare that with the key. This was the original working key that came with the lock, and you can see that the key that we made is nearly identical. Now there is a faster way to make that key. I could just take it, read the wafers, put my blank in here, and read the wafers, how high each wafer is, and go to a code machine and cut the key on the code machine. And that's what we're going to be doing to make car keys. We're not normally going to be filing by hand, but occasionally, as you know, if you took the impressioning course, that to impression the lock, we're going to need to file it by hand. And that often comes into play in automotive work, that will be off a little bit on one cut, and we are going to have to hand file to get the key to work exactly right and to establish the correct cut of the wafer. So we'll see all of that later in the course. Okay, so here, using the key that I filed by hand, I have the lock assembled just to show that the key will work the lock once it's assembled, and you can see that it works very smoothly. So that if you have the lock plug out like this, or even if it's not out of the shell, but you can see the wafers, and you put in an uncut key blank and look at how far it pulls the wafers past the shear line, you can actually read this once you've had a little bit of experience, and it doesn't take long to get pretty good at this. But number 1 cut is a 1 cut. We don't need to do anything to that spot. And also on number 4. And then here's a 2 cut, and then here's a 3 cut, And then here's a 3 cut. So to read this, we have 1, 2, 3, 1, 3. And we can, again, take that to a code machine, any kind of code cutter, cut the key to that combination, and the key will work the lock. Okay, now I've taken the wafers out of our cam lock, and they're arranged in order, 1, 2, 3, 4, and 5. And I'd like to show the differences here at the bottom. Notice how much wider this wafer is at the bottom than right here. And this is the part that the key presses down on. So we had 1, 2, 3, 1, 3. Notice that both of these are 1s. Notice how narrow this bottom component is. The 2 is a little bit wider and therefore requires a deeper cut to get this to come down to the same level as this one. The 3 wafer has even more room here, so it's thicker, so we're going to have to cut the key deeper. Otherwise, it's going to push it down below the 1s and the 2s, isn't it? So we have to adjust the depth of the cut on the key depending on which wafer is in there, and this is the difference in the wafers, is this part down here. So that's what is going on with this with the wafers. As the key goes into the lock, it slides over this bottom part, and if it's the right cut, it will line them all up evenly at the shear lines. I have a drawing here of a wafer lock like the one we just made the key for. Shows a wafer being pushed up by a spring into the wafer chamber to lock the plug, so the lock will not turn. It cannot be opened as long as the wafer is in that position. The key would come in here, pushing down on the wafer, and it would free it from this chamber and allow the plug to turn. Another option is to have opposing wafers, so that instead of only one wafer going up, we have a second wafer being pushed down. In this case, there would be 2 locking chambers for the wafers to go into. This would require a double-bitted key, so that when the key went in, it would push the one wafer down to free it here, and it would push the other wafer up to free that wafer from this chamber. So that would be another example of a wafer lock, and these wafers are referred to as opposing wafers. Okay, another type of wafer lock is what's called a sidebar lock, and it works differently than the other wafer lock that we were looking at and made the key for. The way this works, there's what's called a sidebar that goes out into a sidebar chamber and prevents the plug from turning. The wafers have a notch in them that if the notch lines up with the sidebar, it allows the sidebar to move in or recess into the plug to free it from the shell, and it can turn. So we would have springs on both the sidebar and we would have springs on the wafers. In this example, I have the spring here pushing this wafer up. The key would have to come in down here and pull the wafer down until this notch lined up with the edge of the sidebar. There will be small springs on the sidebar that will push it into that notch and allow the lock to turn. Here's a drawing that shows what the lock would look like in the open position. I didn't draw the key in here, but the key would be inside the lock, again pulling the wafer down, and then the springs would push the sidebar into the notch, and there would be a little gap created here where the sidebar is free of the shell and allow the plug to turn. Here's examples of the different wafers. This is just a standard wafer. Again, there would be a spring that would be putting pressure against his shoulder, pushing this up. Notice there's no sidebar notch on this wafer. This is a sidebar wafer. Notice this little V notch right here in the side. That's where the sidebar would have to slide into when it was lined up appropriately. And then here's another type of sidebar wafer, and the notch is right in here. Here's an example of a sidebar, and sidebar has a V edge. It's going to be hard to see on the video because of the shape of the sidebar, but it has a V edge on one side that would go right into the slot like that. And it doesn't move much. It's a very small movement. It is all that's needed to free the plug so it can turn. Okay, I want to show you another wafer here. And you can see that this wafer looks very similar to the other wafers that we looked at. It has a shoulder here that a spring can fit under to push this wafer either up or down, depending on how it's put into the lock. I'm going to move the spring out of the way for just a minute now. Notice here that there's a cutout here. And this is the main difference in this wafer as compared to the other ones. It's a little smaller here and probably a little bit wider up here. This wafer is out of a high security lock, and it operates the same way as the wafers that we just got through looking at in the little wafer cam lock that we made the key for. The spring pushes it up, the key pushes down against the spring, or vice versa depending on the orientation of the wafer. But you know, this little cut here is where the key rides at, right on this little notch right here. And so these are the keys that you call the laser cut keys, or the side winders, or the side milled keys that you hear people talking about. This would be an example of the type of wafers that are in those locks, and there's very little difference between these and the very first wafers that we looked at. It's just a matter of how the key contacts the wafer. That's the main difference. Now, as we go through this course talking about these locks, I'm going to refer to this piece that the key goes into, the piece with the keyway that turns. I'm going to refer to that as the plug. And whatever the plug goes into, I'm going to call that the shell. So this would be the plug, this would be the shell. Now, if this component goes into something else, then I would call that a housing. But there is a little difference of opinion on the technical use of these terms, and I just want to keep it as simple as I can. I think that if I call this a plug and this a shell, and then whatever this goes into a housing, it's very similar to the terms that you learned in residential and commercial locksmithing. I may not be technically correct in the use of these terms in every single case, but I think if we just have an understanding that's what I'm doing, I think it will make it simpler for you to follow along in the discussion. So for another example, I would call this piece here the plug. It has the keyway in it, and I would call this piece the shell. One other example here. Again, this would be the plug, and this would be the shell. Now, to give you some automotive examples of those types of locks, first we're going to look at this Ford tin cut door lock. Notice that all of the wafers are flush right now because the key is in it. If I take the key out, you see all of the wafers went to one side. So these are not opposing wafers. They all pull to the same direction. Now if you'll look right here, you can see, it's kind of difficult to see, but going towards the bottom of this shell, you can see that this is the wafer chamber, where the wafers are going to go down into that chamber and lock the lock. So with the key in there, they're all lined up. We can put it in there and we can turn it around and so on. But if you watch here in the window, when I pull the key out, you'll see all 6 wafers slide down into the chamber, the locking wafer chamber, like that. They're all down in there now. Starting from the front, there's 1, 2, and then the middle one's 3, 4, and back here 5, 6. Whereas if I look at a Ford 8-cut lock, now this is a Ford 8-cut door lock. It only has 6 wafers in the door lock, but you can see 3 are going one direction and 3 the other. So here's an example of a lock with opposing wafers. Here's an example of a sidebar lock. The sidebar is right here. This happens to be the Ford 10-cut ignition lock also. Notice this cover, which covers the wafers so that the wafers are maintained inside the plug. When the key is in, the sidebar is recessed slightly, allowing the plug to turn. I have the key in the lock now, and if I start to take the key out, you'll see the sidebar pop out. Just takes a little bit of movement with the key and the sidebar will pop out. So that's an example of a sidebar lock. Ford 8-cut ignition lock is a good example of a sidebar lock with opposing wafers. I put the key in, sidebar's right here. If I take the key out, you'll see the sidebar pop out. Now, once the plug is back in the shell, the wafers stay retained in the plug. They do not lock the plug. Only the sidebar locks the plug. But if I take the key out, you will see again that we have opposing wafers. In this case, there's 7 wafers, 4 on one side and 3 on the other. So that's an example of opposing wafers with the sidebar. If you can see in this shell for this lock, this is the chamber for the sidebar. There's no other chambers in the shell for the wafers to lock into. So it's just that one component, the sidebar, that locks the lock. Okay, now on this Ford 10-cut lock, notice that the keyway is offset. It's not in the center. And that's quite often a dead giveaway that you're dealing with a sidebar lock. If you look at this Ford 8-cut lock, that keyway's in the center too, isn't it? But this is also a sidebar lock. So you cannot always tell if you're dealing with sidebar lock simply by looking at where the keyway is located at. I want to review the 4 categories or types of locks that Ford has used for about 50 years now. And the most recent lock, of course, is a high security lock that we're not going to cover on this film. But as this video is being made in 2014, Ford is still using on many of their vehicles an 8-cut lock, which they introduced in 1996. Before that lock came out, Ford was using a 10-cut lock. Both the Ford 8-cut and the Ford 10-cut lock are wafer locks. The 10-cut lock was introduced in 1984 and began to go away by the late 90s, but can still be found on a few cars up through 2002 models. Before the 10-cut lock, Ford was using a 5-pin tumbler lock. From 1965 to 1991, most of their cars were equipped with this 5-cut pin tumbler lock. Now, many of those began to go away when the 10-cut lock was introduced, but they continued to use that 5-cut lock, especially on their heavier pickups, up through 1991. So we are going to go ahead and cover that lock in this course because there are quite a few of those vehicles still on the road today. Before 65, Ford was using a different 5-cut pin tumbler lock. And we're not going to cover that category of locks. I want to just make you aware of it, that if you get a call for a Ford that is made before really 1966, you want to be cautious. They don't always make their transitions all at one time. They begin to introduce the locks, and it can take a long time to phase out the old lock and go completely to the new lock. So anytime you're close to the year of a transition, you want to check and see which particular lock you're dealing with. But from 1956 to 1966, Ford used a 5-cut pin tumbler lock, but it is different from the one that was introduced in 65. So be aware of that it's a different keyway, and takes different tryout keys to make a key for it, and that kind of thing. But in this course, we will make keys for the Ford 8-cut lock system, the Ford 10-cut lock system, and the Ford 5-cut lock system that was in use between 65 and 91. Okay, the first locks that we're going to make a key for will be the Ford 8-cut lock. And again, this is an example of a fairly standard 8-cut ignition lock and an 8-cut door lock. They come in different varieties, so this is kind of the standard, but there are some that look different than from what you see right here. And that's pretty much true for basically every lock. Never expect all of the locks in one category to look the same. With the Ford 8-cut lock, the normal position for the wafers in the door will be wafers 1 through 6. You're going to have 3 on one side and 3 on the other. The odds on one side, the evens on the other. We have to find out which wafer is the deepest, and that's going to be the number 6. Now that is unless we have one of those cars that has 2 through 7. If we have a car that's 2 through 7, the deepest wafer would be a 7. But nearly all of the Ford vehicles have 1 through 6 in the door. And I'll point out the exceptions for the most part that you need to look for. Then the ignition has 7 tumblers in it, 2 through 8. So again, you're going to have the evens on one side and the odds on the other. The second key that we make will be for a 10-cut set. Ford 10-cut sidebar ignition and a Ford 10-cut door lock. For the Ford 10-cut system, the doors have 1 through 6. All of the wafers are on one side. The ignition uses 5 through 10, again all on one side, with 5 and 6 being common to both locks. Now with the Ford 8-cut and Ford 10-cut, you're going to have to just look to see which side the wafers are on. The wafers could be on the top or they could be on the bottom. With the 8-cut, you could have the evens on the top or the evens on the bottom. So you're going to have to look in the lock and make sure that you know which wafers are where before you start making a key. And the third key that we're going to make, actually it'll be 2 keys here because these locks do not take the same key, but these are the pin tumbler locks, 5-cut pin tumbler locks, ignition lock, and a door lock. And I'll show you how to make the keys for these locks. With Ford's pin tumbler locks, you have 5 tumblers in the door. They are normally on the top. In the ignition, you have 5 tumblers in the ignition, and they are normally on the bottom. Okay, we're going to be looking at 4 different tools that are reader type tools that we can use to try to read the wafers in the lock without disassembly of the lock. The first one here is the Cobra reader, which is manufactured by Lockmasters. The second one is called an Easy Reader. The third one is called an AccuReader by Locktech. And the fourth one is a Lishi 2-in-1 tool. All of these are for the Ford 8-cut lock, for the door lock, to measure the wafers that are in positions 1 through 6. Okay, these are the first 2 reader tools that we're going to look at. This one is called a Cobra reader by Lockmasters. The second one is called an Easy Reader. Both of these are for the Ford 8-cut lock. And the way they work is there's going to be obviously a tool we push into the lock. It's going to have a slot. There's going to be a slide that we can push back and forth to release the wafers that are trapped and to measure them. The Easy Reader, the little slide tool comes out, is the main difference with it. The Cobra Reader also has a little light that comes on, which is helpful at night sometimes. Both tools have some type of marking on the reader so you know how far it is into the lock. They both have a scale, and there'll be a mark on the slider that will line up somewhere on the scale. With on this side here towards the tip, this would be a 1 cut, and then going back towards the bow of the key, that would be a 5 cut. The footer's cut towards the bow. So if it were lined up like this right here, that would be a 1 cut. And you can see the same is true for the Easy Reader. I'm going to show you how to use these, but basically now as I'm showing you on the actual vehicle how to use these, it's not that easy to get a close-up of the scale once the key is in the lock. So you can see here that this would be a 3 if it were lined up with the middle mark. There's 5 possible depths on the Ford 8-cut. If it's back here, that would be a 5 cut. You can just barely make out the little mark on the slider. It's lined up with a 5, and then towards the tip of the key, that would be a 1. Now the third reader I'm going to demonstrate is called an AccuReader by Locktech. And again, they have these for different locks. This is for the Ford 8-cut door lock. And you'll notice that they come with 2 reader keys, one for deeper wafers and one for the more shallow wafers. They are numbered on the key. This one here. This is 1 through 4, and then 5 through 8. These can be used in ignition locks if they are non-sidebar locks, and that's why it goes up through 8. The door key obviously only has 6 wafers, but that's why you see the 7 and 8. Now this reader works a little different in that it uses these measuring sticks, and they have one set of measuring sticks for the Huff locks and a set of sticks for the non-Huff locks. And that is a feature that I like about this tool, is that it does distinguish between the 2 locks. There is obviously a slight difference. This little slide tool works much like the little slide tool for the Cobra Reader and the Easy Reader. It's going to, in this case, so it's not going to actually read the wafers. It's only used to get the tool into the lock and then to release the wafers. And again, I'm going to demonstrate that. Just so you can see what I'm doing, is it's going to be easier to show you right here than it is going to be at the vehicle, that once the reader key is trapped the correct wafer, we're going to try each one of the measuring sticks, and we're going to slide it in very carefully. And if it stops here, this is a number 5 reading stick, that would be a 5 cut if it stops there. If it goes on a little further to here, we know that's no, okay, it's not a 5. And then we'd put that measuring stick aside, and we would go to the number 4 measuring stick and just go through like that, 5, 4, 3, 2. When you come to one that works, you stop, and like I say, if none of them work, then you know it's a 1 cut. Okay, now this reading tool is what's called the Leashy 2-in-1 pick and reader. It's for the Ford 8-cut lock, and it picks the lock to an open position, and then it measures the wafer. In my opinion, this is a more accurate measuring device because it actually, the part of the wafer that we're trying to measure, it traps it against the shell. So there's a known distance there. And the way it works, it has a little handle here that acts like a tension tool so you can pick the lock. It's got two picks, one for the top pick, if you look here at the end right here, one for the top wafers and one for the bottom wafers. You can see them both there. There is a scale to help you line up with each of the wafers and then to actually read the wafer. So that now if we take the one where we push up, that's actually reading the bottom wafers, and if we have the pick where we pull down, that's actually the top wafers in most locks. Now again, we have to check and see if the lock is, most locks, the top is going to be the 2, 4, and 6 wafers. But we cannot say absolutely positively that every lock is going to be that way. There are some that are not like that. There are some where 2, 4, and 6 are on the bottom. So again, assuming it's the 2, 4, and 6 are on top, that would be this bottom pick here. And so, for example, if you wanted to read the number 6 wafer, you would simply line up the tip of this little reader on the 6, and that should put the pick right underneath the number 6 wafer, and you pull down. However far it comes down, this is your scale here, depths 1, 2, 3, 4, and 5. If it comes all the way down to here, that's a 1. If it comes to right there, that's a 4. Now you can see there's not much difference, but it is enough. It is enough difference on the scale that you can normally determine the cut of the wafer. So again, I'm going to show you how this works. The one disadvantage of the 2-in-1 pick is that I have found some locks that would not pick open within a reasonable period of time. And I say reasonable, if I spend 10 or 15 minutes, then I think that lock has got some problem that it's not going to pick. Most of them are going to pick, and you'll see me pick it, I don't know, 2 or 3 minutes, the lock should pick open. So the problem with this tool is if the lock does not pick open, you cannot use the reader. But I really do like this tool, and most locks will pick open, but I always carry a backup just in case it won't pick. Okay, now all of these tools, well, the first 3 tools here come with directions, and basically you can simply follow the directions and learn how to use these tools. The Lishi tool does not come with directions. They are available for an extra price. Basically, they have a book that they try to sell on how to use the Lishi tools. But I'm going to show you how to use it, and it's not real difficult, but there's probably tips in their book that may be helpful. Now, as we start talking about vehicle identification, I want to go ahead and talk about the information that you may need to gather before you make a car key, because that's just as important as the vehicle identification. This is different from state to state. You need to check and see what is required. But in California, we're required to get name, address, telephone number, date of birth, driver's license number or ID number. And then we've got to write down the work that's going to be performed. We have to have them sign that. And we have to keep that form for 2 years for any car key that we make. And again, now, it's going to vary from state to state. There may be no requirements, or there may be similar requirements. But I normally go ahead and write the license plate number and the vehicle ID number on the same paper. Now, the first key that we're going to make, I'm going to go ahead and make it for my Ford van. And the way the locks sit on the doors, I think I'll be able to get some good video of that to show you how to use the readers and other tools. And I think it'll work well for that. So I'm going to go ahead and just use my own work van for this particular key, the first key that we're going to make. Now it's a Ford, it's an E150, and I am going to change the locks out after I do this video, so everybody that sees the video is not going to be able to make a key and have access to my van. So I do plan to change the locks out, and we'll see how to do that in one of the later courses. But if we look here, the vehicle ID number, and this is true for every vehicle ID number. If we count over 10 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that 10th digit will tell us what year a vehicle is manufactured. As we can see here that in this vehicle ID number, the 10th digit is a Y. So we'll go to a chart and find out what the Y indicates. Now I'm going to use fast facts to start with here, and I'll show also in some other materials, but if we look here, letter Y right here, we can see it's a 2000. Now it's important to do that, to actually identify the year from the registration, from the VIN number, check and double check and make sure you know what year vehicle you are working on, because you're going to be surprised how many people don't know what year their vehicle is that they're driving. And you start try to make a key for the the wrong year, especially if it has a transponder key in it, there's a real good chance that it's not going to work out well. So always verify that. Then verify the model. The manufacturer is pretty simple. They're going to say Ford or Chrysler or whatever they're going to say, but on the model, again, many people do not know what model of car they are driving. And I have had people tell me the wrong model. When I would be on the phone with them, I would go ahead and start filling a form out like this, and I would write the model in, and when I get there, I double check, and I find out that I've been given the wrong model. So it's important to know that before you start trying to make the key. Here you can see the same chart of information on the back of the Auto Smart book. And most automotive resources are going to have this chart that will allow you to find out what year that 10th digit stands for. Okay, so we're going to turn in the Ford section. Now I'm using the Auto Smart domestic book here for this example. So we're going to turn to the Ford section. We're going to look at the Econoline vans, which here they refer to them as the E-Series vans. We saw from the vehicle ID that it was a 2000, so this says 1997 to 2007. And everything on the chart here, you want to read it and become familiar with it. But I want to point out some things that you want to look at right away, and in particular that you want to look at, that you don't want to miss. So let's zoom in here a little bit. And to start with, the first thing you want to look at is, does this vehicle have a transponder? And right here it says no transponder. Now if it did have a transponder, then you're going to have to find out if a programmer is required to program the key, or if it has onboard programming, and if you have the right transponder key to do that job. This vehicle does not have a transponder. That's one of the reasons I went ahead and chose this vehicle, is because it's pretty straightforward. It is a 8-cut key, which is very, very common on the Ford products today. It has been since about 1995. We're going to talk about that more later, but this is just a good vehicle, I think, to start with. Now, one of the first things you want to look at after you see if it has a transponder or not, what type of key is it? Here it's an H75 key or the Yoko 1196FD. You have to check, do you have those key blanks? Yes, we have those key blanks. You want to pay attention to the code series. You might want to write that down. It could be significant later on if we need to look up anything to do with the code for this particular vehicle. So this code on this series of vans is 001-1706X. The key is double-sided, meaning it has cuts on both sides. We want to go ahead and make a note about this card. CX101 is the code card that we're going to need for our code machine to cut this key. Max, M-A-C-S, maximum adjacent cuts. How much difference can there be between two cuts? The maximum is 2. Some vehicles will be 3, some could be 4. But when you're making a key for a vehicle, it's nice to know, what was allowed by the manufacturer. And so if one cut is a 2, the next cut could not be a 5 because that would be a difference of 3. So we know it cannot be a 5, and that helps us to eliminate cuts by knowing the max. If a cut is a 1, then the next cut could not be a 4 or a 5. Make a note that there are airbags on this vehicle. What type of retainer does the ignition lock have? It's an active retainer, meaning that there's some type of active mechanical device that has to be manipulated, normally a locking wafer that has to be depressed in order to remove that lock cylinder from the vehicle's column or dash. And we're not going to really need to know that for this course, but later on we're going to need to know that kind of information. So you may as well go ahead and get in the habit of looking at that. Space and depth chart is a C, and hints and tips on how to make the first key are on making the first key number 14. Back up a little bit so you can see the book better. Now we just turned. We know that the space and depth chart, it said, was C. And you can see there's all kinds of information. This is a great book to just get into and start. Just study the book. You're going to learn a lot of stuff just spending time with the book. Okay, so these are space and depth charts. Now the space and depth chart that was for this vehicle was C. And we can see it's an 8-cut key. There's 5 depths. And then there's other information on here. Some of it is similar to what we saw in the last chart, but talks about the key blanks again, talks about codes. If you're going to use a Curtis clipper to cut the key, it gives that information. If you're going to use a pack and punch, it tells you what to use there, the pack F3. And I'll talk more about the pack and punch and show you how that works later in the course. We already saw that the max was a 2. It shows the mechanical key here in 875. There is no transponder. We don't need a transponder key. We just need a simple mechanical key to operate this vehicle. So that's the space and depth chart. And then on the tips on how to make the first key, we continue on into the next section, and it will have the information that we're looking for there. Okay, I'm going to back up here so you can see the whole page here. Okay, so notice again, pertinent information on this page. It talks about the code series. It says non-PATS. PATS refers to a transponder system. This vehicle doesn't have a transponder. It shows you here, transponder crossed out. It says no transponders on these models. There are no codes on any locks. No codes on any locks. When this vehicle left the factory, it used 1 key for all the locks. And then there's notes to read. It doesn't hurt to go ahead and read everything on the page and become familiar with it. Then there's different methods to make keys. The first key, to generate a key. It's got 4 methods. One is to use an easy reader, and I'm going to explain that more in just a few minutes. 8-cut determinator is another type of reader. I'm not going to look at the determinators, but I am going to show other types of readers. Tryout keys, I'm going to show you what that is. And then number 4 is to disassemble the door lock, and we're not going to do that. I am going to show you some locks disassembled, but we're not going to actually do that to make the key for this first vehicle. And it goes on to the next page. And again, now there's 2 different charts here. It says 8-cut, non-patch, Aerostar, Expedition, Explore, pickups, vans, and Windstar. Okay, that's going to be the chart that we're going to be interested in looking at. And you can see that this is an 8-cut key, but only the last 7 cuts, 2 through 8, operate the ignition lock. The first 6 cuts operate the door. And of course, this tailgate, storage, and glove box are not going to really apply to this vehicle, although the vehicle does have a total of 4 door locks. All of those door locks are going to be 1 through 6. There's no tailgate, no storage, no glove box lock. Then at the very bottom of the page, it talks about a progression chart. New Ford 8-cut, 96 and up, so on, progression chart. And we are going to talk about this more later on and how to use this chart, as I'm going to show you, more than one way to make this key. We are now going to start making our first key by using the 4 readers I showed earlier. As I demonstrate the Cobra reader, the Easy reader, and the AccuReader, I'm only going to read 3 wafers on video, but hopefully you'll get the idea of how they work. I am not going to use video time to read all 6 wafers in the door lock. I will record the whole process for the Leasy 2-in-1 reader. Now, some of the basic facts about the Ford 8-cut lock system that we want to try to remember. That first off, the lock was introduced in 1996, and so if we get a call for any cars 1996 or later, we need to look and see if we are dealing with the Ford 8-cut system. The locks were manufactured by both Stratec and Hurd. I think Stratec made most of those locks. The locks do use opposing wafers, and the ignition lock may have a sidebar or it may not. They have 2 different ignition locks. The ignition lock has 7 wafers in positions 2 through 8. The doors have 6 wafers, and most all of them are in positions 1 through 6. There are a few models that put the door wafers in positions 2 through 7, primarily talking about the Lincoln LS, the Ford Explorer, and the Mercury Mountaineer. That's where you might find those in positions 2 through 7. The test key is an H75 key blank. Okay, these are the little HPC tools that will hold the dust cap back for you. You could make your own. It's just a little piece of metal with a little slot. It goes in there and it'll lock in there, like so. Then you can take your scope, and it leaves you free to scope the lock. You can go in and rake the tumblers and count the tumblers on the top and then on the bottom. This is a little probe that is pretty handy also for, you can use it both for top and bottom if you want to probe the lock. And one thing that we need to do is make sure that we know which wafers are on top and which ones are on the bottom. We can't just assume that the top wafers are 2, 4, and 6. It could be reversed, and that's true for many locks. You really need to check every lock to make sure that you know which wafers are where. Now I want to find out which wafers are the deepest, the top wafers or the bottom wafers. Which ones go in back into the lock the deepest. And one technique I've come up with is I'll take a key extractor and put a little masking tape on it. Go all the way in. I'm going to do the top wafers first. Go all the way in and come back and catch that top wafer and put a mark on my tape. And then I'll take that out. I'm going to go ahead and make the mark all the way around so we can see both sides. And now I'm going to do the bottom ones. And you can see that the mark is out about a quarter of an inch right there more. So the top wafers are the deepest wafers. So if this is wafers 1 through 6, 6 being the last wafer, that would have to be on the top. So we have confirmed that 2, 4, and 6 are on the top, and 1, 3, and 5 are on the bottom. Okay, we've already sprayed this electronic cleaner, which acts as a degreaser into the lock. It's the grease out of it and helps the tumblers to move a little bit better. We're also going to use a little bit of lubricant. It's designed for locks. This is called Lock Shot. Then we're going to take a key, and of course this is H75 Ford 8-cut lock, and we're going to put a key in there and just run it back and forth a little bit. Try to make sure that all of the tumblers are freed up and sliding very easily. Okay, now we're going to do the Cobra tool, and again this tool has the slide captured in the tool, which is one convenience of this tool. It also has, as I showed earlier, it has a little light that lights up. If it's night, that can be helpful. Again, we're doing the bottom one, so we're going to slide the tool in, pull the slide back, come back and catch the number 5. Okay, so we put slight pressure inward on the tool, push the slide in, just so it touches the wafer, and then the scale's up in here. And this actually reads about a 1.5. So it probably is a 2, but we're going to go ahead and write down 1.5. So we're going to write down the number 5 as a 1.5. Then we push the slide in to release the tool. Get back a little bit, pull the key tool back a little bit, pull the wafer reader out, and capture the number 3 wafer. Again, putting pressure, a little bit of pressure inward, push the wafer reader in, just till it barely touches, and again we're going to read right in here in this scale here. This is the number 3 wafer, reads a 3. So we push the slide in, release it, back the key up a little bit, pull the slide back out, and trap the number 1 wafer. Jiggle it around a little bit, put a little pressure in, push the scale reader in. The number 1 reads a 3. Okay, so that's the 1, 3, and 5. We can go ahead and push the slide reader in and take that tool out. Okay, so with the Cobra reader, we're now going to read the wafers on the top, which are 2, 4, and 6. Okay, so we're using the Easy Reader to measure these wafers. And remember, the 2, 4, and 6 wafers are on the top. 1, 3, and 5 are on the bottom. And now if you have a lock that is 2 through 7, this reader will also read the 2 through 7. But this lock is 1 through 6. So we have the slot facing up, we have the slide tool in place. If the slide tool is not in place, the slot is going to get held up on the wafers and it's not going to go all the way to the back. So make sure that the slide tool is covering that slot push the key all the way in, pull it back to catch the number 6 wafer. Jiggle the key around a little bit, and now we're going to read that wafer. Get your slide tool lined up, put a little bit of pressure inward towards the lock, and then very gently push the slide tool in. Once it touches the wafer, then we take our reading off of the scale right here, and we can see that this one reads a 3. Now, you push the slide tool in to release the wafer, pull the key back just a little bit, take your slide tool out, and continue to pull the key back until you catch the next wafer, which will be the number 4 wafer. Again, jiggle it around a little bit, put the slide tool back in, put a little bit of pressure inward on the key, and then very gently push the slide tool in until it touches the wafer, and then again we will read our scale. This wafer also reads a 3. Push your slide tool in to release that wafer, bring the key back, catch your next wafer, which will be your number 2 wafer. Put the slide tool back in, we'll jiggle it around good. Put the slide tool back in, pressure inward, and then very gently again, push the slide tool in. On the scale, this time we can see we have a 4. The little mark on the slide reader lines up with the 4th mark on the scales, so this wafer reads as a 4. I want to point out in the instructions with this easy reader that it says that it will not work with Huff locks. It says most notably the Focus Escape and the Moss Attribute. And for those, they recommend a different easy reader called the Focus 7. So you really want to pay attention to if you're working on a Huff lock or not. Okay, now here's a drawing of the face of a lock as to what a Huff lock would look like. You can see that it has a different looking face for the keyway. So if you see one like this on a Ford 8 cut, that would be a Huff. The standard non-Huff looks like this. We're going to use the AccuReader tool now. And you remember with the AccuReader, there's 2 different keys, one for the deep wafers and one for the closer wafers. This key is for number 5 through 8, and we're going to be doing the bottom wafers, which are 1, 3, and 5. So we're going to use that one. Use the slider to put the key in, take the slider out, pull the key back until it catches the number 5 wafer. And I think you heard that probably even pop up in there. We're going to jiggle the key, make sure it's up in there good. And then we use the number 5 depth first to check and see if it's a number 5. We put the little slider into the slot on the key and push it in. Try to hold the key level and push the little reader tool in. And we can see if we look right here, we see it went to the 2nd mark, which means no, it's not a 5. So we take the little 5 reader tool out. And next, we try our number 4 depth. See if the number 4 depth is a yes or a no. And again, if we look right here, we can see that number 4 went to the no mark. So it is not a number 4. So we have to take that out and we try our number 3 depth. Again, hold the key level. Push the little reader tool in, says no. And the number 2 depth, there is no number 1 depth. If it's not a number 2, then we know it's a number 1. And that actually stopped on the yes mark. So we know that we should record this as a number 2 depth. So that's the number 5 wafer would be a number 2. Okay, we use our slide tool and take this key out, completely out. we get the key that's for reading wafers 1 through 4. Put the slide tool in to cover the slot, push the key in, take the slide tool out, and bring it back, and that should catch on the number 3 wafer. They're numbered here on the bottom of the key, and the 3 is right even with the keyway. And so this should be correct in the number 3 wafer. Okay, so we have the number 5 reader. We push the number 5 reader in. It goes to the no, it says no. So then we get the number 4 reader. Number 4 is a no. Number 3. Three is a no. We use the number 2. Number 2 says yes. So for the number 3 spot, we record a number 2. Then we use our slide release and back the key up to the number 1 wafer. Do the same thing again, starting with number 5. No. And number 4. No. And number 3. Number 3 measures a no. And then we'll check number 2. Number 2 says yes. Stopped on the yes right here. So we record number 1 as a 2. Then we take our slide release tool and take that out. We're going to read the wafers on the top, wafers 2, 4, and 6. And we catch the number 6 wafer, jiggle it real good. Take your number 5 depth tool, slide it in and see if it says yes or no. Says no. Take your 4 depth tool, slide it in. Says no. And then take your number 3, slide it in. And it stops on a yes. So for the number 6 wafer, we would record a 3. Okay, this leasing tool, again, it's got the 2 different parts that move in here, and we need to get them lined up so that they will go into the keyway and get it pushed up all the way in there good. And then we can pull these slide tools. These are actually the picks and the readers. We can pull those back. Now our first job is going to be to pick this lock open. And we know on the bottom we got 1, 3, and 5. And on the top we have 2, 4, and 6 wafers. And we have the scale, which I showed earlier, that if we simply line up with the correct number, it should be on top of that wafer. So if I come down with this one like this, obviously the other end's going up. So this is going to be 1 or 2, 4, and 6. And this other one will be doing 1, 3, and 5. So I'm going to just start with this 1, 3, and 5. And just kind of feel for them. Now I'm going to put slight pressure, slight turning pressure, just like we're picking the lock, and let's see which ones are bound up now. Okay, we're going to do 2, 4, and 6. Okay, number 6 just picked. Number 4 just picked. Let's try the 1, 3, and 5. 5 is given no resistance really. 1, 3, and 5 are no resistance. Let's try 4 and 6 again. Okay, 1's a little tight there. Maybe 1 will pick, but let's try 3. Okay, 3 went. Let's try 1 again. Let's try the number 2. We have to continue to go back and check on all of them to make sure they didn't slip. 1 does not want to give way. I'm going to back the pressure off a little bit and see if it'll, I think it went then. 1, 3. Let's try 2, 4, and 6. There's 2. The only one I'm not sure about here is 5. I think the other ones have moved. But the lock hasn't released yet, so we know at least one of them is still holding. There we go. So now the lock is picked to an open position. So the next job will be to actually read the wafers, and we'll simply come with again our reader on the number 1 wafer position. We come up and it shows a 2. So in the first position, and these lines are very close together, but I would say that's a 2. Okay, we're going to get number 3. Number 3 shows a 2. In the number 5 position, number 5 really shows a 1. Okay, then doing the ones on the top, we're going to do number 2. Number 2 shows a 4. Number 4 is a 3. And number 6 is a 3. So that's what we get from using the Lishi tool. These are the cuts that we measured with our 4 different readers. The cuts listed across the top: 1, 2, 3, 4, 5, and 6. Then we have the Cobra reader, the Easy reader, the Accu reader, and the Lishi. Now we can see there are some discrepancies. In cut number 1, we got 2 3s and 2 2s. Cut number 2 is all 4s, so we can be pretty sure that that's the right cut there. 3, we have a discrepancy with two number 3s and then 2 number 2s. Number 4, we got all 3s, so again we're pretty sure that's probably going to be correct. Number 5, we have 2 that we measured at 1.5. We got a number 2 and then we got a number 1. And if you recall, on the Lishi tool, I mentioned that I was having a hard time really feeling this cut, which really indicates to me that it very likely could be a number 1 cut. And then on number 6 cut, we have all 3s, so we can be pretty confident that we have a number 3 in the number 6 position. Now what I'm going to recommend that we do, let's cut a key that's a 2, because we have a discrepancy here. Let's go with the smallest cut. Then let's go with a 4. Here, again, we have a discrepancy. Let's cut a 2. Here we have a 3. On number 5, we're going to cut a 1. And number 6, we're going to cut a 3. And then we're going to try that key and see if it will work. So I'm going to go to the code machine and cut a key like that, and then we'll try it out. Okay, now this is the HPC 1200 code cutting machine, and I've shown this machine in other videos, and so I'm not going to go over it except just in basic explanation here. I'm not going to go into a lot of detail on this machine. But for people that may have not seen the other videos, this machine will cut keys by code. Okay, it has two handles, like an X and Y axis. One that sets the space, the correct space, and that would be this handle here. And the other cuts the depth, indicates the depth. We have cards that just slide in here, and this is the card for the 4 to 8 cut locks. This card number is CX101. Now you want to make sure you have the right cutter wheel on your machine, as well as of course the right card. We're going to cut the cuts 1, 3, and 5 on one side of the key blank, 2, 4, and 6 on the other. So the 1 was a 2, the 3 was a 2, and the 5 was a 1. So we're on the 1 here. We're going to cut a 2. We're going to go to 3, and we're going to cut a 2. And number 5 is no cut. This is the key that I just cut on the code machine. 1, 3, and 5 cuts are on one side, and I put a little mark on the handle on the bow to remind me which side was the number 1 cut side, because the number 1 cut was down, so we have to turn it down or it's not going to work. You'll notice I just made 3 cuts on each side. 1, 3, and 5 on one side. Now number 5 was a 1 cut, which actually is no cut. So that's why there's no notch in the number 5 spot. And then on the other side, the 2, 4, and 6 cuts. And I do that so that if the key doesn't work, hopefully it's going to leave an impression mark in one of these locations, and it's going to be easier to identify the problem cut and correct it if we only have 3 on each side to start with. Once we have a working key, we'll put all 6 cuts on both sides of the key. Okay, so we're going to put the notch down, so that indicates the number 1 cut. The number 1 cut is down. Put the key in, and we can see that that key works good. Now, if there was a problem and it didn't turn the lock smoothly, it should leave an impression mark on one of the cuts, and we could identify which cut needed to go deeper. But this key is perfect. These are the cuts that we need to put now on both sides of the key. And then we'll need to work on getting cuts 7 and 8 for the ignition. So I'm going to go ahead and put the cuts on both sides of the key, and then I'll show you how we're going to complete the key. Okay, so here we can see the key with all 6 cuts on both sides of the key. And again, we'll check it in the door lock and make sure it's good, but I did that and the key works fine. So now we're going to get on to making the cuts number 7 and number 8 so this key will fit the ignition lock. I'm going to use my iPad, and we're going to go online to Black Hawk products. Now there's a number of companies that offer the kind of service I'm going to show you now, which is a fill program to fill missing cuts. This is the one I use, but like I say, there are other companies that do this. The website for Black Hawk products is blackhawk7.com. Go to their website, I choose online services, and they have several different services they offer. The one we're interested in right now would be Fill Online. So we're going to go to that. We're working with a Ford 8-cut lock. So we will choose right here, Ford 8-cut. Then it's going to ask for my username and password, and then we fill the code in here. The cuts that we know. We had 242, 313. Now there's two more cuts that we need to know about, so we're going to put in 2 question marks, and we're going to have this program make a chart for us with the possible cuts. I already came up with only 2 cuts. Oftentimes there's going to be more than this, but with this particular lock here, it says with the combination that we have, the 2, 4, 2, 3, 1, 3 cuts, there's only 2 possible cuts for the ignition. So the number 7 cut is going to be 1, the 8 cut 2, or it's going to be 4, 3. So we're going to progression the cut down, and by what I mean by progression is that we're going to cut this first cut, the 1, 2. The 4, 3 are deeper. So we're going to do the 1, 2, we're going to try that. If that doesn't work, then we're going to just cut the same key, the same 2 cuts down to a 4, 3, and see which one of the two keys will work. I did our first cuts, 1 and a 2, 1 and a 2. This is the ignition lock. Anyway, this doesn't work. This does not turn the ignition lock. So I'm going to have to cut this down, number 7 down to a 4, and number 8 down to a 3. So I'll go to the code machine and do that. So I'm back, and I made the 4 cut and then the 3 cut on the number 8 position on both sides of the key, and this should work because there were only 2 possibilities, and we can see that it works quite smoothly. Try your key on both sides to make sure both sides are accurate. So we made a key for the door locks and the ignition locks. Now, as we found out, the cuts that actually worked were these cuts 2, 4, 2, 3, 1, 3. The only reader that we used that was right on the money was the Leasy reader. The next most accurate reader was the AccuReader, and it had them all but 1 cut were right on. The other 2 cut readers were a little further off, and what we would normally do, again, is hopefully the car has more than 1 lock that you can read. And normally you are better off reading the passenger side door as opposed to the driver's side door. Now in this case, we used a driver's side door lock, and we used an older lock that I was pretty sure had quite a bit of wear to it, so that I could demonstrate the differences that you're going to find among these readers. But I have learned that with using the Cobra reader and the Easy reader, one thing that I'll do is I will push in as I'm taking my reading. I'll put a little pressure inward and do a reading, and then I'll pull out and do a little pressure outward and do a reading like that. And the same with the Easy reader, and just see what the differences are. Most of the manufacturers recommend that inward pressure will give a better reading, but I have found that it's worth looking to see what you get if you put outward pressure on the tumbler as you're reading it. The other thing that I have learned is that, especially if the locks are worn, the Cobra and the Easy readers in particular are more likely to read a little higher than they should, as they did in this case here. And what I would normally do, if the only reader I had was a Cobra reader, I would cut this key to 1 cut less. I'd go, obviously on the 5 I would cut it to a 1, but I would cut 2, 3, 2, 2, 1, 2. I would cut them 1 cut less, because if a lock is worn down, the tumblers will read deeper than they should. And if that didn't work, I would cut them to 2.5, 3.5, 2.5, 2.5, 1.5, 2.5, and see if that would work. And hopefully that would work, and I'd be able to get impression marks and then impression the key down from there. The same is true with the Easy reader. Also with the AccuReader, if I cut this with the AccuReader and it did not work, I would cut another key and I would cut them back a half a cut. 1.5, 3.5, 1.5, 2.5, 1.5, 2.5. and again see if I could find impression marks and make the key that way. I tried these readers in the passenger side door, and the AccuReader came out right on. It was only off one cut on the driver's side door. And again, that could have been something that I did. Maybe I didn't hold the key exactly level or whatever. But the AccuReader measured all of the cuts correctly. These were the correct cuts here, 242, 313. Using the Cobra reader, you remember the first time the Cobra reader was off on this cut and this cut, and then we had a 1.5 here. In the passenger side door, it did better. It got this one correct, this one's correct. This one here is still measured off 1. The 1 came right on the 1, so that was better, but the 6 cut was off. And on the Easy Reader, it was only off on the number 6. It was off by 1 here. And again, this could be something that I did by not holding the tool totally accurate, or it could be the wafer just didn't come up that time all the way into the gap to measure it. So my advice would be to get some of each of these, try them for yourself, keep some records as to how accurate they are for you, and then form your own opinion as to which ones that you like. But this will not work every time. It's probably successful in making maybe 80% of the keys. So what are you going to do if you cannot make the key from the readers? The next thing that we're going to use would be tryout keys.